Okay guys, so explain the difference between each type of triangle and draw a picture. So isosceles, it has two congruent base angles, and as you follow those congruent base angles up, you have two congruent legs. Where those two congruent legs come together, that is called your vertex. So, two congruent sides and two congruent base angles. These two are congruent. All right, equilateral, all sides are going to be the same measure, whatever that measure might be, and all angles will be equal to 60. So all sides are congruent and all angles equal 60 degrees. Scaling, kind of like a poor sad soul. No sides or angles are congruent. So none of them. No sides or angles are congruent. Moving along. What type of triangle has a hypotenuse? Whoops. Draw the triangle. So a right triangle. A right triangle has a hypotenuse. And the hypotenuse is always directly across from the 90-degree angle. Hypotenuse. Right here, this guy right here. And think of it as across from the right angle. Okay, what type of triangle has a vertex angle? Well, we just talked about it, but an isosceles triangle. And it's right where the two congruent legs meet up, right there. CPCTC stands for corresponding parts of congruent triangles are congruent. And when you use it in a proof, after you've proved the triangles are congruent, to show various parts are congruent. Okay, so the big thing about this one right here is if you turn it, you can see this is an isosceles triangle. So that means that this angle and this angle are congruent, right? So what we're going to do is to solve for x is we're going to take these two congruent sides and set them equal to each other. So I'm going to do 3x plus 14 equals 7x minus 12. So I'm going to subtract a little, and I'm going to get 4x minus 12 equals 14. And then I'm going to, not 12, 2. 2. Then I'm going to add 2 and get 16. Why do I keep writing 12? Equals 4x. Divide by 4, and x equals 4. Okay, for y, this is actually pretty cool because if this is 3y, this is also 3y. So I'm going to do 2 times 3y, because there's 2 of them, plus 2y, and set it equal to 180 because the angles of a triangle add to 180. So 6y plus 2y equals 180, which is going to be 8y equals 180. Divide by 8 and you get y equals 22.5. Okay, so solve for the measure of angle solve for x if the measure of angle AED, which is right here, equals 2x, and the measure of AEG equals 5x minus 2. Well, together those form a straight line. They're a linear pair, so we're going to set it equal to 180. So 26 plus 5x minus 2 equals 180. So 5x, when I combine like terms, plus 24 wait, did I set that up wrong? AED. Oh, I did. That's 2x. Whoops. 2x, so that's going to be 7x. Wow. Let me just write this all over. Okay. 2x plus 5x minus 2 equals 180. 7x equals 182 because I add 2 and add 2. And then I divide by 7 and divide by 7. And I get x equals 26. Okay, again, I see that this is an isosceles triangle, so this angle and this angle are congruent. I'm going to set them equal. So 2x equals 3x minus 18. Why do I keep writing 6 instead of an x? So what I'm going to do here is I'm going to subtract 3x and subtract 3x, and I'm going to get negative x equals negative 18. I got to get rid of that negative 1, so I end up with x equals 18. Okay, so moving right along, I'm going to do this one right here. So, use the figure below to solve for x. Well, this is a tricky one because it doesn't really tell you any information besides showing that these two angles are congruent. As a result, you know these two sides are congruent. It's an isosceles triangle. Two congruent base angles means two congruent sides. So I'm going to set them equal. 5x minus 8 equals 2x plus 10. I'll subtract 2 and get 3x minus 8 equals 10. And I'll add 8 and get 3x equals 18. And x equals 6. Okay, well this is nice because there's a right angle. Then I know the three angles of a triangle add to 180. So I'm going to do x plus 19 plus 2x plus 11 plus 90, because that's what that symbol represents, equals 180. I'm going to go ahead and combine my like terms. I'm going to get 3x, and I'm going to add these others, so that would be 101, which would be sorry, I'm doing this wrong. 19 plus 11 plus 90 equals 120, and still equal to 180. I'll subtract 120 from both sides and get 3x equals 60. Divide by 3, and x equals 20. Okay, so right here, we've got to pay attention to the order. So A and F, they line up. And B and G line up. And then we'll put a heart around C and H. So we start with G, which we look and that has a bar underneath it. So that means we'd have to look and, oh, B has a bar underneath it. So B would come first this time, based on the order they gave us here. And then H, and I look, okay, H has a heart, C has a heart. So C goes next. And then F, oh, that was a circle, and that matched with A. So B, C, A. Okay, next up, are they congruent? And why? All right, so it tells us that AB is equal to CD. Okay, we also know that they share this side, and we know that AB and CD, these guys are also parallel. which means that this angle and this angle would be congruent to each other. So that would be side, angle, side, right? We have a side right here, we have an angle, and then we have another side. So SAS and A, B, D. So I started with no marking. I followed it here down to that angle. So C over to D and down to B. Okay, RC bisects HRT, so from H to R to T, it bisects it, giving two congruent angles. And then it also tells us that H and T are congruent. Don't forget that they have the shared side. So technically we have an angle, and then another side. So angle, angle, side. And RTC is congruent to RHC. Okay, so that's the end of that one, and we're going to move on to transformations here. Okay, so translate 2 units to the right. That means I'm going to do 1 plus 2 and -3 plus 6 because I'm moving up. So my new point is going to be 3, 3. All right, so rotate 180. So think of it as x, y. Well, then it becomes -x, -y, or you can use your patty paper. So that's going to be -3, 1. Rotating counterclockwise, well, if you have your x and your y, the rule is -y, x, and you're going to end up with -4, -2. Remember, they switch places, the y becomes opposite. And 43, the rule here, 2, -7, the x, if we reflect over the y, the x becomes opposite. So right here is my x. It's going to become -2, and then the y stays the same. -2, -7. When you reflect over the x, the y becomes opposite. And so I look here, and I have -5, -4, because my y, which was once positive, is now opposite. Okay, so this one is a little bit trickier. It might be easier if you do some patty paper. But you're going to have x, y, and then y, x. So -2, 3. So they simply switch places. When it's y equals -x, they switch places and they become opposite values. So you have x, y, and then they switch places and become opposite values. So +4, 2. And that's it for this video. So that was chapters 4 and chapter 9.